Good day, viewers. You are welcome back to Tindanious Math and Science tutorials. We've already set the ball rolling. We've started treating Moivre's theorem, right? And we've solved some examples. I want you to really appreciate Moivre's theorem. So we will have to solve more examples to throw more light on the topic. So, we have question on the board. 1 plus I root 3 all over the expression 1 minus I root 3 all raised to an exponent of 10. We are going to employ Moivre's theorem over here. So let's look for modulus R, which is okay. Before we do that, let's try to simplify this expression. Okay, so let's discard the exponent first. What happens? I have 1 plus I, then root 3 all over 1 minus I, then root 3. And remember, I've treated questions like this when you tackle introduction to complex numbers. Kindly visit my previous lecture videos where I've dealt with introduction to complex numbers into details. Addition of complex numbers is there, subtraction of complex numbers, multiplication of complex numbers, and division or quotient of complex numbers. So this is division of complex numbers. So you have questions regarding this. You tackle the denominator. You find or look for the conjugate of the denominator. Then you multiply it by the numerator and the denominator of its conjugate. So the conjugate of this is negative. It will be plus. So I multiply this by its conjugate. 1 plus I root 3, then times its conjugate, which is 1 plus I root 3. So I have 1 plus I root 3 multiplying 1 plus I root 3 all over 1 minus I root 3 multiplying 1 plus I then root 3 this way. You can decide to use difference of two squares, but let's follow the formalities. Can use difference of two squares to get your answer quickly. So 1 multiplies every expression here, right? So I have 1 multiplying 1 plus I root 3. Then I root 3. This will multiply the other expression. We have 1 plus I, then root 3. This way. Then all over, I have 1 multiplying this expression. 1, and I have 1 plus I root 3. Then minus I root 3, multiplying 1 plus I root what? Root 3. 1 by this is the same as this expression. I have 1 plus I, then root 3, then plus the I root 3 times 1 gives this. I have I root 3. Now I have plus I times I gives what? I what? Squared. Then I have root 3 times root 3. So you pick 1, root 3, because we have 2 there. So raise to an exponent of 2. Then all over 1 times this gives 1 plus I root 3. Then negative I root 3 times 1 is negative I root 3. Then we have negative I times I gives I squared times root 3 times root 3. We have it to be what? Root 3 all squared. So I have 1 plus I root 3 then plus I root 3, then I squared is the same as what? -1. Remember, I squared is the same as negative what? 1. So I have here will be negative because of the I squared times this. Then 2 takes off the radical sign, right? So I have only 3 times, let's say times 3 this way. Then all over have 1 plus I root 3 minus I root 3, then minus, remember I squared is the same as what? -1. So because of this I squared, I have negative over here, -1. Then times 2 takes off the radical sign, you have what? 3. So times 3. So we have 1 plus I root 3 plus I root 3 gives what? 2 I root what? 3. Negative times 3 or -1 times 3 is the same as what? -3. Then all over I have 1, then positive I root 3 cancels negative I root 3. So we have negative by negative gives positive. Positive 1 times 3 is what? It's 3. So therefore I have, that's 1, let's do like things. I have 1 minus 3, then plus 2 I root 3 all over 3 by 3 plus 1 is 4. So this is the same as -2, then plus, you can write this as 2 root 3 I over 4. And this is the same as this. We have -2 plus 2 root 3I all on 4, right? This is the same as -2 over this 4, -2 over this, then the whole of this over this, then plus 2 root 3I over 4. This becomes what? -half. Then plus 1 on 2. Okay, 2 divide itself 1 and divide it 2 times. Then I have root 3I. So this is the same as -1 over 2 plus I have 1 on 2 and I root 3. As simple as that. So viewers, the whole of this expression alone without the power is this. So I can say that therefore the question, which is 1 plus root 3, that's 1 plus I root 3 over 1 minus I root 3 exponent 10 is the same as the one we simplify, which is -1 on 2 plus 1 on 2 I root 3 exponent 10. As simple as that. So I can do this. Straight away I can look for my modulus R. I can say R is equal to square root of, you square the real part, okay, then you square the imaginary part. So I have -1 over 2 all squared, then plus I have this 1 over 2, then root 3 all what? All squared. So I have R is equal to, this becomes 1 over 4, then plus, this is the same as 1 over 4, then times 3. So R is equal to 1 over 4, then plus 3 over 4, which is equal to, I have 4 on 4, which is equal to 4 divided of 1, okay? So I have 1. And square root of 1 is what? Is 1. Step by step. So having done this, let's look for our argument, okay? Which is the angle. So the angle we have theta is equal to, which is tan inverse of, what is, okay, y over what? Over x. Is that not so? So we have theta is equal to tan inverse of, what is x? This is my x, US here. This is x and this is y. So I can say that we have 1 over 2 root 3, then all over the x, which is 1 over 2. Remember, for the angle, when you have negative, discard the negative, okay? Work with the positive. Or you can just find for the absolute value of the negative, then you get positive. So now, these two cancels these two, right? So we have theta is equal to tan inverse of root 3, which is equal to 60 degrees. So having done this, you ask yourself, this angle, is it the true angle? Is that the reference angle? Is that the argument? Is that the amplitude? Let's find out using Jane Roberts Argand diagram. So using the Argand diagram, I have negative x-axis and I have positive imaginary axis. So if I draw my complex plane this way, I have negative half, okay, on the x-axis. So here I have negative 1 on 2. Then positive imaginary axis, which is my y. There it is. Let's say 1 on 2 root 3. Let's look out for the point of intersection. So there it is, and I have here. This is their intersection, okay? So I'll draw a straight line from the origin to pass through it. And that will be my modulus r, which is equal to 1 over here. Now let's look for the angle. That's the reference angle over here. And remember, please, if you are new here, kindly visit my previous lecture videos on Argand diagram. These things are well explained. So this is the second quadrant. And the second quadrant, you say that you subtract the angle from 180 minus our angle theta. There is it. So our reference angle becomes 180 minus the angle we had. There's the angle, which is what? 60 degrees. 60 degrees is not the true angle, okay? So 60 degrees. So I have my reference angle now is equal to 120 degrees. So I can use this angle, not my 60 degrees. Now employing De Moivre's theorem, so using De Moivre's theorem, I can say that the complex number z raised to an exponent of the power here, say 10, is equal to my modulus, which is r raised to an exponent of n. And my modulus here by r is what? Is 1 over here. So 1 to the power 10. Then we have cos of n times theta. What is my theta? Theta is this, right? 120 times my n. What is my n? My n is 10. Okay, this is my n is 10. So times 10. Then plus I sine. And I have 120 20 times 10 this way. Okay? So this becomes z to the power 10 is equal to 1. So 1, then we have cos 1200 degrees plus I sine 1200 degrees. Viewers, this is the end of the question. You can decide this is the same as that. Because when one multiplies this, you still get this, as simple as that. So you can be given questions where you have to employ the Moivre's theory and Argand diagram. Okay, let's solve the second question. Okay, this is the second question. Now we are supposed to find for this. You can see root 3 here, so you can factor root 3 out. And that is simply your modulus. You don't need to calculate for any modulus. This is already in the polar form, right? So I have root 3 this way, then I have cos 2 pi over 9. Then I have minus I, root 3 is already gone. I have sine, then 2 pi over 9 this way. So I can do this. Six. Okay. So if that is the case, we know that, take note of something over here. The complex number z in polar form is equal to, we have r, then have cos theta plus I sine theta. Is that also? Yes. So this is your r, cos, sine. But you realize this is positive, this is negative. So you have to manipulate this to become something like this before we can proceed. So we are going to employ negative angles from the idea of trigonometry. So negative angle, when we have sine of negative theta, it gives negative sine theta. When we have cos of negative theta, it gives positive cos theta. When we have tan of negative theta, we have negative tan theta. So we are going to incorporate this into this. So here we have cos and sine. So we are going to focus on these two, cos and sine. So having done that, I can clearly say root 3, then viewers, this is the positive theta, this is the theta, this is the positive angle, right? So if I have positive angle for cos, positive angle, when I negate that angle, it's still the same. So I can just negate this, right? So I can say cos then of negative 2 pi over 9. And I haven't changed anything at all. So for this, so this is the same as I have, this simply means negative sine. So negative I sine, you get that rule, like this. They have 2 pi over 9. I can decide to do this way. I can say I have positive, then I sine, then I have negative 2 pi over 9 this way. Because positive times negative gives what? Negative. But I decided to push the negative to the angle side, the argument side. It's just the same thing. So having done that, I can say that using the Moivre's theorem, we can say that, you know that the Moivre's theorem says that you have z to the power n is equal to r to the power n multiplying cos then n theta plus I sine then n what? theta. So we know that n is equal to 6. Then r is what? Root 3. Then now our angle here we have what? Negative 2 pi over 9. So let's do that. So for want of space, I can say z to the power n. What is my n? N is 6. Then my modulus is root 3. Then raised to the power what? 6. Then I have cos. I have n times 6. Okay. This is the n, which is 6 times the angle. This is the angle. Okay. This is the angle. This is the angle. So I have negative 2 pi over 9, then plus sine, then I have 6 times negative 2 pi over 9. So 3, okay, so I can multiply or I can divide 2 by 3. So I can say that z exponent 6 is equal to root 3 to the power 6, and I have cos 6 by 2, we have negative 12 pi over 9 this way, then plus I sine of negative 12 pi over 9 this way. Okay, so we can say that z exponent 6 we can say that z exponent 6 is equal to, this is 27, then we have cos 3 goes into here, 3 divides here 4, so 4, then we have what? 3. So I have cos negative 4 pi on 3 this way, then I have plus sine, so let me do it this way so that it will be okay, negative 4 pi on 3. Then I have negative 4 pi on 3. As simple as that. So, to conclude, I can say that z to the power 6 is equal to 27. This is the same as cos, then positive. Okay, so I can say 4 pi on 3. Remember, I said for the negative angles, when this is negative theta, right? When I maintain the angle to be as positive, it's still the same. Okay, so negative, then I change it to positive, it's still the same. Then my negative comes here, then my positive goes there. Then I have I sine, and I have 4 pi on 3. I've done it in such a way, if the angle here is positive, it's positive for both. If it is negative, negative for both. You can see negative, negative, positive, positive. Do you get it that way? So viewers, this is the end of the tutorial. You can decide to multiply through 27 by this minus 27 by that, just to change it to the rectangular form. Bye.